A diode looks like this. A diode is a two-terminal electronic component that conducts current primarily in one direction. It has low, ideally zero resistance in one direction, and high resistance in the other. Here is the symbol of the diode. The triangle implies the p-type side, and the line implies the n-type side. A diode conducts electricity when the current flow is in a specific direction. When we change the direction of the current flow, then the resistance of the diode increases drastically. Then the diode doesn't conduct the electricity. This is a silicon atom. It has 4 electrons in its valence shell. This is a phosphorus atom. It has 5 electrons in its valence shell. This is a boron atom. It has 3 valence electrons in its valence shell. Let's observe how the diodes are made. First, let's take a semiconductor such as silicon. This silicon is way purer. Here we can observe the lattice of pure silicon. The silicon atoms are bonded with each other by the covalent bonds. There are no free electrons or empty spaces. Doping is an intentional introduction of impurities into a semiconductor for the purpose of modulating its electrical, optical and structural properties. Now the phosphorus is doped into the silicon. It's done by various complex processes, but I had shown it in an easy way. This phosphorus-doped silicon is referred to as N-type. N implies negative, since there are free electrons. This is the lattice of the N-type mixture. There are free electrons present in the mixture. These are electrons of the phosphorus atom which are not bonded. These free electrons are being attracted by various atoms' nucleus. These are constantly moving in the mixture. Now the boron is doped into the silicon. It's done by various complex processes, but I had shown it in an easy way. This boron-doped silicon is referred to as p-type. P implies positive, since there is a lack of electrons or the existence of empty spaces. This is the lattice of the p-type mixture. There are holes present in the mixture. These holes are present due to the lack of electrons. The electrons of beside atoms constantly move to the holes. By assembling the p-type and n-type materials linearly as indicated makes up a p-n junction. By connecting terminals to either side of the junction, we get a diode. Let's observe how the diode functions. Let's take the previous p-n junction and observe the changes in it. There are free electrons in the n-type material and holes in the p-type. At the connection between p and n-type, the electrons in the n-type material which are near to the p-type material moves to the holes in the p-type material. This creates a neutral zone known as depletion layer. To allow the current to flow, a voltage must be applied to it. In this video, when I refer to the moving of holes, I mean the electrons of the beside atoms in p-type material take the place of the hole. This changes the position of the hole. Placing a negative terminal near the boron atom shifts the electron to the position of the hole. A hole builds up in this place as the electron moves to the positive terminal. This change in position is similar to a moving hole. Hence it's conveyed and compared to moving holes. First, let's bring out this circuit by connecting a diode as shown. We will observe another possibility next. As you can see, the negative terminal of the cell repels the electrons, as well as the electrons come out from the negative terminal of the cell as shown. The voltage makes the electron gain the potential barrier. This allows the flow of electrons. The electrons also fill the holes in the p-type material. Hence there is current flow. By placing a bulb in the circuit, it glows. We successfully made a circuit by using a diode and made the bulb glow. This connection is known as forward bias since there is electron flow. First, let's bring out this circuit by connecting a diode as shown. This is another possibility of a previous arrangement of the diode. All the electrons in the n-type material are attracted to the positive terminal of the cell. As you can see, the negative terminal of the cell repels the electrons. The electrons are being repelled towards the depletion region. This propels the movement of holes. As you can see, the depletion layer broadens. This prevents the flow of electrons. Hence there is no flow of electrons in the circuit. This is known as reverse bias since there is no flow of electrons. Let's observe the two types of bias by representing the diode with its symbol. Let's glimpse at the uses of the diodes. These are present in almost every electrical device. The frequent one is the LED, light-emitting diode. It is used in converting AC current to DC current. And there are many more uses. Like and share this video. Subscribe to this channel. Click below to visit and subscribe to our channel.